Hello again and welcome back to another Wild tutorial. Today we will be measuring the temperature using a thermistor. This is basically a type of resistor whose resistance varies significantly with temperature, so we're going to be using that to measure the temperature. The one we have here is a TTC05103, and the other parts we need to complete this circuit are another resistor, a couple of wires, a breadboard, and of course our Intel Galileo. Now, you can look at this circuit like a voltage divider circuit, and the way this works is it produces an output voltage which is a fraction of its input voltage. Okay, so let's see about the circuit now. This is my thermistor. It has 103 written on it. On one of its legs I shall connect another resistor, and one of these cables which goes right here in the input on pin A5. I also have to connect the other leg of the resistor to the ground, so I'm going to connect this here and here. And on the other leg of the thermistor I have to connect 5 volts. Okay, now I'm back in my interface. First thing we need to do is create a new application. I'm going to call it thermistor, and then click next and submit. Then find its name and click it. Now the first thing we're going to have to do is find out what voltage is measured on pin 5. So that will be a ratio of 1023, and apply that to the reference voltage, which is 5. So I need to set, first of all, a variable called B, and this will be 4050 based on the specifications of my thermistor. Then what we need to do is create a loop. I'll repeat this every half a second, so that's 500 milliseconds. Okay, so let's add a new variable here called V measured. And that will basically be the voltage that I get in my analog input multiplied by 5. Okay, so I'm going to add these two blocks from numbers and math here, duplicate this so that I can multiply it by 5. And divide by 1023. Now I need to add the block that reads the value, and I need to make sure that this is a real number. So please drag this block here, and now it's a real number based on the analog read on pin 5. Okay, let's continue. We need to add a new variable here, calculating the resistance of the thermistor every half a second. The formula for that is 5 over the volume that I just measured minus 1, and all of this multiplied by 10,000. So I'm going to add this multiplied by 10,000 here, and then add another block. So this will be the minus 1 part, and add another block like this one, which will calculate 5 over the volume that I measured. Oh, sorry, that's just 5. Divided by V measured, which I calculated above. Now the temperature I'm going to get is calculated by a pretty complicated formula, so I'm going to need to have a temporary ratio here, just so that the formula doesn't get too complex for me. So this ratio will be 1 divided by b, the b that I said above, all of this multiplied by the natural logarithm of the resistance of the thermistor divided by 10,000. Okay, I need to make sure that 1 over b is calculated as a real number, not as an integer, so add a real number block as well. Okay, so it's 1 divided by b, the real number. Basically, we're doing this in order to persuade the program to calculate that as a float. Otherwise, the numbers that we would get would be imprecise. They would be natural numbers. Okay, so it's 1 divided by b multiplied by the natural logarithm is here, and we have to compute the natural logarithm of the resistance of the thermistor divided by 10,000. So we need another block here. Duplicate this variable block and select the resistance of the thermistor. Okay, now we can actually proceed to compute the temperature. So set a new variable called temperature. We also have a pretty complicated function here. So basically it's 1 over 298, which is 273 plus 25. That's the temperature in degrees Celsius at which the thermistor is calibrated. Okay, so that's 1 divided by 298. Again, make sure this is a real number because we want this fraction to be as precise as possible, plus the ratio. Now, in order to display the actual temperature, we need to take into account that the formula is valid for Kelvin. So we need to subtract 273 from this value that we get. All we need now is to have a way to show the signal. So I'm going to add a thermometer here. How fitting. Make sure that the signal's name is temperature. And now we can proceed to run the application. Okay. As you can see, my thermometer is already reading 22 degrees. And now I'm going to touch the thermistor, and the values are already increasing quite rapidly. They're at 27, 28, 29 already. And now I'm going to let go of the thermistor, and the values are decreasing. We're at 28. Okay, thank you for watching.